Okay. Mm, I'm just gonna put my own face on here, but it might be easier with that. Whatever. You still see my screen, right?
Yeah, can see arc.
Bend is a massively parallel high-level language, unlike CUDA and Metal. I have yet to use CUDA. I've tried a little bit of Metal recently, ever since getting a Vision Pro, and I'm not a fan of Metal.
Hmm. Yeah, so I've never personally tried any kind of high performance GPU language before, so this should be interesting. Yeah, I mean the syntax makes it look like Python, and I was reading a little bit about the this sort of combinator calculus that it's based on, which I guess is some big idea about what makes
Yeah,
a language good at expressing parallelizable operations, but never seen anything like that in practice before.
yeah, that's why I'm interested to try this out because this is definitely leaning on the power of its big idea and of some guy spending a long time implementing and in particular optimizing it.
Yeah.
Since I took a brief look at the optimal lambda calculus papers, including Lamping's, and well, they're all written well before 2000, but no one really did anything with them besides some Haskell library that
Hmm.
just sort of languished as usual. Oh wow, his thing is really blown up. I remember when this had less than 100 stars, and now it's almost 12,000 or 11,000.
Yeah, pretty cool.
Good job, Victor. Okay, how do we install it? First, install Rust Nightly. Well, that's easy. We already have it.
Will it run
Okay.
on Metal? Do you have a
Yeah,
MacBook
yeah.
I see? Do you have like a M one, two, three
No.
capable MacBook?
I have an M2, but it's as he says, note only NVIDIA GPUs are supported at the moment.
Okay, yeah.
Okay,
Yeah,
let's see.
disappointing.
Do you have an NVIDIA GPU? If not, we can just spin something
I
up.
do not. I do not have a
Okay, yes, we're
NVIDIA
spinning
GPU.
something up then.
Okay.
Add that to the to-do list. Spin up something with. I do want to try it on Mac to see if it'll run though.
Yeah, for sure.
Um, Mm.
Let's see, did like what editor do you use for programming here? Do we have like
This is
does
just the
this link is this
terminal.
yeah, I was gonna say, is
And
this like language advanced enough to have like some syntax highlighting capability, or is it just gonna be,
no way, no
you know,
way.
okay,
Although for editing, I use cursor, and before that, Neogun.
okay.
What's this called? Sort. Different. Running it this way, I think, is just the serial implementation. Okay, it apparently will run on a Mac, just not all that fast.
Okay. Well, yeah, so to be expected that it's not gonna run quite as fast as it would on a high-end GPU, but that's okay.
4 seconds. Okay, time to spin up an NVIDIA GPU. I wonder if any NVIDIA. Oh yeah, it's just CUDA, so probably any NVIDIA GPU will work. Paper space. Sure. Actually, I have Colab, and that should have GPU access. This might work actually. So install HVM on here using a bunch of its shell commands, and then also in its shell just run the what's its name, the command, and then set the runtime to have yeah, why not an A100?
I don't know, is this collab thing gonna like charge you a ton of money for renting out a A100 for a while?
I pay it for
I've
the
never
monthly.
rented it. Hmm,
I have their Pro Plus membership, which is like 50 a month, where
okay,
even with this, you can still get disconnected on jobs.
I see. Okay, well,
But hey, an A100, which at a minimum has 40 gigs of RAM and hopefully 80. Hmm, what shell is this running? Bash. Right. Right, even this has AI support these days. Oh yeah, I need it to run nightly. Function add. Oh yeah, I need to append this to path. This is in there anyway. Oh, I hate that. You have to essentially run it in one large block. Argon, yes, reinstall HVM.
Where it doesn't.
Doesn't look like it.
I mean, it gives me the impression of being like a notebook where you could just like run commands and have them like have like a persistent environment now. So you're saying that like you can't run line 8 there in a new command? That's weird.
In fact, it seems slightly worse than that because it just says rust C command not found.
Hmm. Need
And
to
it
like
did,
install
it did,
rust C.
but rust C was just installed. And look at line 5, which is supposed to source the file in question. Seems like even between shell command invocations.
Hmm.
Oh, that's annoying, but not like the end of the world. And still free. How did I just make it? Oh. Looking for a way to just make a new file directly.
Okay, you've got the sort.bend file.
Yeah. Mm, yeah, actually, exactly the command I wanted. Bash RC or bash profile though. Bend from. I figure out where the file even would be. What's its path? Copy. Oh, thanks, Google. Uncontact. Failed to install bend line. Is it not called bend line? Oh, maybe I bend run kudo. Okay, 11 seconds. User 10 seconds. 0.21 seconds.
It's about tracks, right?
0.33 seconds. 0.21.
Wait, is this being run on? You gave the command to run on the CUDA, right? So
Yeah.
wait, why is it taking like 11 seconds to run? Getting scammed here.
Bend run kudo. No such file address. No such file or directory. Mm.
We've seen that the directory is there.
You, try to cut out the CUDA. That'll make no. It's unlikely the issues would have that, but just in case. Yeah. The strange thing is running it once, it seemed to actually work. It spit out like 166, and not on this one though.
So let's see, what are the contents of so this is sort.bend.
Yeah.
Does this come from some example file?
Yeah, it's one of his
Examples.
there.
Okay. What's the input to what it sorts?
Some
It just
18.
generates some random stuff. Okay.
I think this is supposed to be a tree, possibly of depth 18, and so potentially what, 2 to the 18 nodes, which is 262,144.
Right.
Mm, also, I should tweet that we are doing this. Yeah, we get the link from YouTube. Maybe Victor will come in. Yeah, Twitter. Hello.
Yeah.
Hey, Bolt.
What's up?
Do you have a Twitter?
Yeah. So it's I think it's fog of chess, all lowercase, one word.
Are you a
Yeah,
fan
that
of
looks
chess?
right. It was a username I chose long ago. I play chess online sometimes, so comes from my live chess account.
Mm, okay. So they can get away with just doing this or not. Okay, trying to do in collab. Something to do with how it's interpreting the file. But it can't find it since everything else can.
Right. So this is the bend executable itself that's not being able to find the file. Maybe it needs to be in the same directory as it in order to run it. I don't know. Can you like CD into the directory?
The thing is that I apparently am in the same directory.
Well, let's see. Are you in this? I thought I saw you putting in like the path to the file.
Earlier the
Okay.
content, yeah.
Sort.bend. That makes sense. So you're in the same directory.
Also from that node. Check if this command works.
Like
Okay,
maybe it's
good.
like contrary wise, perhaps like it always expects to have like a relative path from root or something like that. So maybe what you need to do is put in like the complete path, even when you're uh like
Alright, the room.
none of these are working. Huh. OS error too. Not a very descriptive.
No such file.
Right.
How do I do this? Data slash wow, that's cursed. Just in case it's the name somehow, I'm gonna try it. No. I think this file. Print to. It actually. Did it actually run it or just defines it? Mm, Let's trace them. Okay, let's see if this has anything useful. Oh, I think I know what's wrong.
Yeah.
It's looking for HVM with a relative path and HVM the subcommand that I just cargo installed also. And so the file that
Okay.
doesn't exist is HVM, which suggests adding it to the path should do something.
Yeah. Could it be looking for the file relative to the path that the executable is in? Seems hard to say.
Okay, it's running. User video, user code. Okay. Cargo is indeed not in the path, but this appears to work because it prints 2 at the end, which is what I replaced the sort.bend file with.
To sort.
Okay, that was pretty fast.
Let's see, what is it printing out here? The main is the sum of the values that we sorted. Okay, so like, yes, clearly we sorted them, but we also sum them. Sure.
Okay, there. This is more promising. And let's compare it to the other versions of Bend. Run C and run coup.
I guess it's just going to take forever to run it on the CPU.
Yeah, in retrospect, I should have done them in the opposite order, but whatever. Okay, it really does take forever. How'd you find lean, by the way?
Um, so I think I initially found lean. It was something that my advisor suggested to me. It was when I was first signing on with him. I want we he had suggested this project about formalizing snarks, there was one of a couple languages he proposed, but I had heard of lean because I had played the natural number game before, which was this sort of introductory tutorial to
Yeah,
lean. Um,
I've done
and
it.
so when that, yeah, yeah. So at that point, I was like, okay, I'll just use lean to sort of take on this project, and then like 3 years later, here I am.
Here you are. Okay. So the CUDA version is definitely faster.
Yeah, for sure. One
Let's
minute,
see.
30 seconds, and then 16 seconds. And
And then
then the
zero point
CUDA
0.6
version
seconds.
is like 0.6 seconds. Sweet.
And let's see, what kind of performance does this one claim? Ah, here. On an RTX 4090, zero point 0.2 seconds. Okay, well, it's not zero point 0.2 seconds.
I mean, presumably it depends on is this the same file? This is the Bitonic sorter that we've got running.
Yeah. Hmm.
Hmm.
He might have modified the Bitonic sorter slightly. I did click on that blue link that just says file, though.
Okay. Yeah, so it's about consistent, right? If we
Actually,
divide
notice
everything
this.
by
Yeah,
I mean,
I was just
another
thinking
thing
for
to observe is that like the CPU on the Apple M3 Max they ran it on might not be the same as the CPU on the A100. So
oh, definitely
doesn't
not.
necessarily mean that all these things should line up in the same ratios, but it makes some amount of sense that it would be about 2 orders of magnitude faster, I guess.
We can, in fact, just test it on the Mac because it seems like if it will take advantage of multi-threading and if it's outputting to some intermediate C code, well, I mean, I have more than one thread, more than one core.
Yeah, for sure. Um, let's see.
Cool.
I mean, in principle, I should be able to do this too. Here, I've like while this has been happening, I like have gone through the installation instructions on my own. Um,
Here, we could
so
switch
if
where
I do
you,
run C,
like, you can share your screen there.
um, yeah, okay, sure.
Okay, then I'll stop
I
share.
can share my screen. This on full screen. Move this back down. Share my screen. This one. Share. Okay, so this should be my screen.
Yeah, I see
And
it.
we have
4 blue.
sort bend here, sort dot bend. And now presumably we can run this and we'll see how long it takes. And look, so we've got our result back, which is the same result, I think. I should run like the time it command. What is it? Time? Is it time or time it? Time.
Try time it.
Let's see.
Time will work,
Is
but it'll
there
run
like
it
is
only
this
once. I think time it. No,
time?
and you don't have it.
Okay. My is something I can like spend. Perhaps it's something I can install in another. Right. Okay. So it gives out the same. Takes 21.79 seconds. That seems a little bit too long. Maybe this is like CPU, like total like CPU time, I guess. And presumably I won't be able to run it on a GPU because I don't have one.
Yeah.
But the other way that I can run this is just by running it. And we can see how long it takes on a single core. Time bend. So what's the difference between time and time it? Time versus time it. CLI. Oh, is time it like a Python thing? All I'm getting is like Python has time it.
Yeah, I think it is a Python thing.
Okay, interesting. Um, okay, so we've come back with this. And what does
Oh,
it
it's 23
say has been the
seconds.
case? Yeah, 22.5 seconds total. Um, so that's running it without the GPU. So it's yeah, again, it's like about one order of magnitude faster to do it with multiple cores. I mean, this is like a let me recall facts about the Mac. Um, and
If you hit
one
once,
max. I
it'll
don't
give you a
remember how
chip
many
count.
cores. Shit, but I don't know what the
System report, the bottom one.
yes, system report. Great. Total
So
number
we'll
of
core
cores
10.
10, and it's about factor 10 speed up. Makes perfect sense. Okay, guess we're in the massively parallel setting here.
Take a look at that system report. 12. 8
12.
performance,
Yeah,
4 efficiency.
yeah,
If
sure.
I run it, let's see.
Okay, let's see. Are there examples of other here, let me I'm gonna do this. Why don't I put this here? And see, are there any other interesting examples we can run? We have like this form of sorter, Bytonic sort. This is one of those that like looks at the like takes advantage of the representation of what's being sorted.
Alt tree, fusing knot. Here, take a look at the Fibonacci one. Why not? That's a classic.
Yeah, for sure. Right, Fibonacci.
Can you make it bigger?
Yeah, for sure. How's this?
Yeah, that's good.
Fib.mend. Okay, let's take a look at how it's implemented. So like one would assume that it's implemented in the naive way in order to best accentuate
Yeah.
the like speed of parallelization. So fib lambda x switch x. If x is equal to 0, then return
One.
1. Is that right? I
Yeah.
thought that 0 fib of 0 was supposed to be 0. Maybe I'm wrong about that. 1 1 2 3 5. No, fib of 0 is supposed to be 0. But I guess that's neither here nor there. 0 will return 1. Otherwise, let p equals x minus 1 switch on p. If that is 0, return 1. Otherwise, we run add on fib p and fib p minus 1. Makes sense to me. So let's see how long it takes. Let's see if I really can't get like time it to work. I guess not. Too bad.
I'll look at Hyperfine. Hyperfine is a Rust library for doing command line benchmarking.
Super fine. Okay. CUDA. Oh no, did I put in
Oh
CU?
well.
Yeah. CUDA runtime not available. Okay, so clearly it needs to not be CU, it needs to be C. And this completes in about 0.09 seconds total. Okay, very fine. If I delete the C until it's run on one core, it takes about half a second, which is a little bit more. So again, that makes a lot of sense. You said you wanted to like implement matrix multiplication,
Yeah.
right?
Yeah,
Okay, so
let's
we
do
can take a
that.
look into doing that.
Make
Okay,
a new
so how
file like
exactly does
matmul.
sort work? Yeah, for sure. Matmul.bend.
Actually, a couple of
Okay, so
implementations of it. One of them being a straight up for loop, even if that doesn't expose any parallelism. But starting
right.
there. Then we could write it as a series of dot products, which we could parallelize at the dot level. Like see how much work we have to do to expose it. Like if the central claim is true, anytime we expose parallelism, we should see something for it.
Okay. So matmul, we'll call this matmul one.
Looking for
So I have
Ben's
to,
documentation for, and also it has a for loop. Dot markdown.
I mean, one thing that I'm sort of noticing
Mm-hmm.
is that none of these none of these examples really like show how you can get data from an outside source. They all sort of seem to like generate their own data basically. So I
Yeah, I
guess maybe
imagine the
that is
IO
how we should
system is
approach it
just
as
like
well.
not there.
Yeah. So this is how they generate numbers to sort. Okay, they always pass around this depth parameter here. Switch D. If 0, return X.
Mm.
Otherwise, I guess the point is, okay, yeah, this is how they sort of generate a range, right? So if 0, they return X. Otherwise, they like multiply by 2 and add 1, and they multiply by 2 and they generate on those.
Mm-hmm. The sum. Mm.
It returns a tuple, I guess.
In the case
But
of
either
summing, it's
returns
also
X or
working
it
on a
returns a
tree.
tuple.
Okay, it looks like one approach of theirs is turn every array thing into a tree thing.
Right. Yeah, I see what you're saying. Right. So we have this tree, and the base, like the leaves of the tree, are just like particular values. And so I think like what this ends up being is it's just a large tree. I mean, okay, so the times two is after the times two plus one. So presumably what this is generating is a large tree, binary tree, with all of the numbers from 0 to 2 to the d minus 1, where 2 to the
Mm-hmm.
d minus 1 is the first value that we get, and it goes all the way down to 0. And that makes it interesting to sort. Um, okay, so if we want to generate a matrix,
I'm seeing if this even
uh,
has a built-in list data type or anything like this.
yeah, good question.
Here, I'll take over screen share for a second.
Yeah, sure. Here, I'll stop.
Here, take a look. Lists, which on Pythons are stored as array are represented using data types in Bend. Okay, using the sort of linked list representation.
Okay.
Obviously, that's terrible. Okay, so they do have a list
Const
data
head,
type.
comma, tilde tail.
What I'm getting
So
from this is that they do have a list data type.
yeah, that seems reasonable. And we can match on it presumably using the like usual functional list matching style.
Why return, not print? Oh, well, for now, you'll read those words a lot. Yeah, I bet. Ben doesn't have IO. Fine. Okay, return 122 then. Expected two spaces dot really? Interesting.
Yeah, that's one thing I noticed. All of the indentation is like two spaces. That's sort of weird and inconsistent with Python, but
This bit is reminding me of Lean's mutable notation, which, man, I'm so glad it exists.
yeah, Lean is like very similar to Rust in a lot of linguistic aspects.
I'm particularly grateful for the ability to write mutables and for loops, since it's just easier to think about a single object than the entire collection, to the point there's even a tactic intro.
Hmm.
Like, rather than thinking of the optimal combination of map, filter, fold to solve some problem, I just like sort of mess around with for loops until it works on one input, then I generalize the loop.
Yeah, for sure.
Folds and bends. And bends. Okay, so that's the serial way to write a sum. Oh, fold is actually built in. Works as search and replace.
So I guess tilde is the like is the sort of like fixed point variable. And this is what allows us to create recursive data types.
It's the first time I've ever wanted a recursive implementation of matrix multiplication. That doesn't look right.
No, it's giving you Strassen multiplication.
Yeah, not what I want. Yeah, this indexing trick of their index times 2 plus 0 plus 1.
Yeah, always this to like, generate things on the fly because all their examples can't use IO.
As an exercise, useful to implement a reverse algorithm for lists. Okay, sure. Not a manual, but seems a worthy task nonetheless. I'm getting my iPad so I can actually break this one out. I can also do one more thing, actually. I can. Oh, right. I was going to index this whole repo in cursor. And also HVM. Okay. What is the usual way of reversing a list?
It's like a classic, it's classic functional programming. Gotcha. Like the usual way is not the most efficient way, really. And so you're supposed to make like a auxiliary function, which gives you like two
But I have
stacks, and you
some.
push things from one stack, put,
Okay.
push things onto the other stack from the first stack. I mean, if we're doing it in parallel though, like presumably you could like split both sides of the list in two and then reverse both sides.
I could do
Does
something.
reverse like I mean it would make more sense for trees really than it would for low level functions.
Okay, well, I know the reverse of a singleton and empty list is just themselves. Back to, then I swap them. Case left, right, somehow, right, left.
Like do we have like a concatenation operation? The so like the most naive way to do it is to say like okay, reverse of x tail is reverse of tail concatenated with a singleton list containing x.
This,
Yeah, that looks right. Is that valid Bend syntax? Does Bend have these like dot 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 operation that you can do?
Apparently not. With index. I don't know if the returns are actually necessary, but it's a comment character. Looks like no. Okay, well, just taking his code for a tree of left and right. Like this. Emulator starts as an empty list with active. Because the volt has to have a starting value too, and I think this is the syntax to give that starting value. Is there anyone in the chat? Let's see. I always forget to check the chat, but it's empty anyway.
Yeah. Yeah, it looks like there's no real good way of like getting notifications if I try to look into that.
Also, wait, since it does a fold, is it doing a right fold or left fold? Okay, the squiggly means. Oh, it just has the same type. What the hell? What button did I press? List. No or comments. Yeah, no. See if this runs with expected syntax. Expected a new line detected. Oh, okay, that was just as simple as that. You actually do need a new line, new line. Two. Curious what kind of error this will give. Redefinition. I'm just thinking it's worth writing some helper to convert between list and tree. Like in the case of a list, to turn it into a binary tree from the very outset. Let the algorithms always work with a tree, and then have some other helper to convert it back into a list for visualization.
Right.
Anyway, to
Hmm.
the depth to list.
I mean, is this not effectively how exactly do the example ones handle it? They have their sort of generator, which gets passed around.
Say that again. Switch now.
Yeah, it's I'm just yeah, not sure what the in this generator here that you're looking at, is it the case that these components of the return, like is this should I think of this return as a tuple? Should I think of it as a tree, as like a node in a tree? Is it possible to return arbitrarily large things
It looks
from
like
this return value?
it's a tree represented implicitly by a bunch of tuples, which looks like it will be roughly balanced. But it's like tuples of
Yeah.
pairs of tuples of pairs of tuples all the way down.
Okay. So you could represent your list for this in some way. You could like decompose. The thing is, like everything here seems to like have its like depth, has its size like carried around with it. So perhaps you would need that, right? So if like thinking like if you have a list that you want to convert into a tree, you're going to want to know what the depth of the tree is. to start out with.
I see how this ends up in everything's parameters then. What I would like is
In
for
principle, I
reversing
suppose
only
you
to
could,
split it in half.
yeah.
You're saying in principle what?
I mean, in principle, you could sort of infer as you go, like, okay, I don't know what size this list is going to be from the beginning, but okay, I'll just build up one tree with the first part of the list I can muster, and then if there's more list, then I can build up a tree from the rest of the list and merge that with the tree that I already have, and keep going until I detect that the list is empty. Um, that seems like a lot of sort of casework, though. And I'm not sure like what is the plan. Everything in all of the example files deals with like binary trees and things that seem perfectly binary. So perhaps that's the easiest way.
Because what I have the eye towards is implementing a dot product. And then dot product,
Yeah,
since it's a sum of products, well, then all the products can be split and then the sum can be done in parallel too. And
right.
then back to
So
the
I
tree
mean,
representation.
yeah. So my thinking is that right. Like I guess the point is that you want to do this in a more naive way, right? If we were just doing this all in terms of the like implicit binary trees composed out of tuples, what we would do is we would just say, okay, a dot product of one of those tuples is you take the dot product of each of the individual components of the tuple and then you sum those up. You would be able to write
Wait,
that. But
you can share this part actually. That
yeah, sure.
looks, it
Um,
looks good.
so I'm going about trying to like implement this matmul thing. Um, and
Oh,
so
nice. Okay, good.
I've modified gen to now do four things. So it's like it's a four array tree um,
Hmm.
for like square matrices, right? A square matrix of dimension two to the t two to the d by two to the d. And I'm trying to implement this matrix multiplication function for it now, which
Definition
works
is too
by,
large for HVM.
yeah, I'm not exactly sure. Like, is it truly the case that this is too large? Not exactly sure what it's complaining about here.
Like,
Please break it into smaller pieces.
try just commenting out the last two lines and add the missing paren. See if it'll error with a different size. Like size
Commenting
93,
out which ones?
lines 17 and 18. Because it says in definition
Right.
matmul, so it's in this function.
Yeah, okay.
I'm guessing the 93
So if I
means
just do
93
this,
characters.
of course it's not. By the way, are we sure that this is like the comment syntax for this language, by the way? Hopefully it
He
is.
uses hash marks everywhere.
Okay, so that seemed to have been successful. Yeah, so it was really just worried about the returning this like four-way thing. Have I even got like a correct implementation of matrix multiplication here though? Hmm.
Well, now you commented out, no. How come you made it split four ways instead of just two?
The, I mean the thing that I think is maybe different is that well I made it split four ways because I wanted to be able to represent it as a right if a list if we were composing our lists as like one-dimensional objects which are binary trees, then to make the matrices I would want to have quaternary trees or tetrary trees. But I'm not sure what the correct root is. But that like the thing that I'm noticing is that it's not necessarily going to be the case that addition is implemented for these like tree types. So I'm wondering how this is not horribly bugged because presumably I would when I like add so if I have a two, if D equals two, then those should be 4 by 4 matrices. Um, and when I go
It's
to
oh,
add
I know
recursively
why.
add the subsets, yeah,
Because
what's the answer?
the reason it works is because you're it's A and B are both well gens, so generators of functions. And then if you look at gen, the final case analysis is to just return a raw integer. And so so its type is really just int, where the tree is completely implicit.
The final case of gen is to return an integer? No, isn't it to return this tuple that I have here?
Oh yeah, you're right. I'm just no. Hmm.
Like what I should really do is I should define something like def add mat, which will come with its D value and A and B. And if case is 0, then I return A plus B because in that case we just have integer literals, not literal, sorry, but we just have integer values. And in the recursive case, what we want to do is we want to add mat D minus 1 on A0. This isn't quite what we want to do.
Yeah,
What
I
we
don't
want
think
to
you want to
do
index into three
is,
and two either.
yeah, so what we want is that A0, A1
B0,
equals
B1.
A, B0, B1 equals B. And then what I want to return is this, right? There's well okay, but there's actually even more here. No. This return value is fine actually, right? I can delete this. This makes perfect sense because what I want to do is I want to get so this is the upper quadrant. This is the upper left
Oh yeah.
quadrant, the upper right quadrant, the lower left quadrant, and the lower right quadrant. And I just want to add all of those individually, recursively, using add mat for D minus one dimensional, or for, sorry, for D
Mhm.
minus one order matrices. And that seems fine. Um, and so the key way that the matrix multiplication needs to change now is instead of this, what I want to do is add mat. Uh, and I want to add mat them as matrices of order D minus one, I think. It's going to just be easier to let Copilot complete it for me, but it'll probably be something like this. Yeah, 0, 1, 1, 3, 2, 0, 3, 2,
2,
2,
1,
1, 3,
3,
3.
3.
And I guess it needs a closing parenthesis. So this looks like it would be, I just want to like check in my mind that the order of the matrices is right. Because the point is that matmul is what we do to multiply matrices of order D. Matmul D is what we do to multiply matrices of order D. And the return of matmul with type D minus one is going to be a matmul of it's going to be a matrix of order D minus one. And so I do want the order D minus one addition function. That seems right to me. Okay, so let's see if this works.
Or if you're going to hit a definition too big.
I'd
Parentheses.
expected, I expected a parenthesis here. In fact, VS Code was smart enough to tell me about that. But it's still complaining about too large a size.
Well, let's see. Let's focus more.
It only complains about matmul, not add mat. So
It's
it's
because
not like
it's
fundamentally wrong to have a for tuple here. What was your
it's
explanation of this?
it's literally that the definition has too much text in it.
Oh, hmm. Sorry, is it literally that there's like 101 characters in the
I think so, yeah. Maybe not counting
500?
comments, but yeah.
Hmm.
I don't know why.
Interesting. Well, okay. Please break. I wonder if I can break it into smaller pieces. I could like define the like add upper left, derive upper right. I could like sort of break all of these down. That just it strikes me as a very so you're saying that it's literally the language is like parsing this definition and it's saying it's too long. That sort of strikes me as a strange thing for a language to complain about. It like seems like it would be easier just to let
Definition
people
is too
define things of
large.
arbitrary size.
I'm going to take a look in the HVM source code. The phrase
Yeah,
definition is too large. It should be in the error
yeah, I would be
messages
interested
somewhere.
what you find. Here, do you want to share your screen while you do that so that I can see what's
Yeah,
going
okay.
on?
What's the exact error message you got?
The exact error message is in definition matmul, definition is too large for HVM. Size equals, yeah, like open paren, size equals 101, comma, max size equals 64, close paren. Please break it into smaller pieces.
Check
Okay,
net
there.
size.
This is that at the very top is the error that I'm getting.
Check net sizes.
Net sizes. Hmm.
Where is this used?
Make the check optional. Is there a way that I can make the check optional?
Is that
The commit message suggests that there's a way of making it optional, but I don't know if we know what that way is.
I'm just gonna look in what diff of the source code. Okay, dash O no check net size.
Dash O, okay, yeah, great. Dash big, is that an O? Okay, let's try
I
that.
think it's O for
Run
option.
matmul one. Yes. Dash capital O, no check net size. Net size. Okay, what happens now? Okay, wonderful. I have a result. Here, I can
Okay.
share my screen
Yeah, let's see it.
now that we've succeeded in this. Continue. Start to share. So I have successfully
Uh,
gotten this result, which is the what the matrix multiplication thing is returned. It doesn't
I have
look like
no
it
idea
has
if
the
that's
right
right.
form.
Also, those numbers just seem suspicious to me.
These numbers seem suspicious. What I was expecting was like, right, it's of order two. So it should be a 4 by 4 matrix. Are there 16 numbers here? There are 16
Yeah,
numbers there.
there are 16.
Okay. Is it okay? Here's an interesting question. What I did not really expect to see was this.
Well, like this nested
But I'm
structure.
like perhaps this is no, actually this might make sense. because well, I think that like maybe four tuples are just represented in terms of lower order tuples. So a four tuple is really a tuple of two things, one of which is a tuple, right? A four
Yeah,
tuple is just
probably.
a tuple of a tuple of a tuple, right? Um,
Yeah, the standard inductive. I think he mentions this actually.
okay, so like first, like here's maybe something that I can do to like sort of try and figure out what's going on. I can get a readout of what A is. A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And B should be the same thing because
Okay,
it's
well,
defined exactly the same.
I'm just gonna run in Python to figure out what this should actually be.
Yeah, yeah.
Equals numpy a range of six.
Well, I mean, be careful though, because I think that the matrix, what is the underlying matrix that this represents? I think it's like 0, 1, right? It's a matrix where the upper left quadrant of the matrix is 0, 1, 2, 3, and then the upper right quadrant of the matrix is 4, 5, 6, 7.
Okay, if you don't do it like that, and it's just 0 through 15 row by row, then the upper left would be 0, 1, 4, 5, aka a different
Hmm.
matrix. Here, let's try just beating it out manually. Array.
Here, I can also like run this entire thing with d equals 1, and maybe that would be easier to debug.
Maybe a bit too
When
easy.
d equals
Two.
1, 0, 1, 2, 3, that's sort of as expected. C, 18, 18, 18, 18. That doesn't seem right to me. I have 0, 1, 2, 3, 0, 1, 2, 3. Surely the upper left component should be like 3, right? Or 2.
I'm just gonna multiply. Yeah, the top left should be 2, then 6 below it. Upper right would be 3. Oh, it should
So
be 2,
obviously I
3,
have
6,
some
11.
2, 3, 6, 11. That sounds about right. So what have I done wrong here? Just confirm. This should be 0, 1, 2, 3.
That was 0, 1,
I
2,
guess
3.
like maybe the key thing to do here is start debugging this way. So like what happens if I print out this thing, which is supposed to be um,
Hmm. Unbound variable D.
yeah, so this result is giving me 18, which seems very suspicious. Um, if so A0 is supposed to be 0 here. So let's like just try replacing these one at a time. Okay, why is yeah, A0 is equal to 0. I'm suspecting like what does A0 mean? Is this not how we unpack A properly?
Well, if you just print out A0, like just have it return
Right.
A0. You could just put it above,
A
I think.
zero.
Sure.
Oh yeah, yeah. Okay.
3.
Result is 3. That's not
That's
right.
not that's
So
not
A
what I was
zero.
expecting.
Yeah, it should be 1, right? Because if I print out A, it's this. Oh, is it in the opposite order? What is A1, for example? 3.
Also
All of the
3?
values are 3.
Okay. You might as well print
I'm
out
beginning
A2
to
then.
suspect that like this index, the list index notation is not what I thought it would be.
Okay, if you do A2, was that also going to be 3?
Let's check.
Yeah.
Result is 3. Is there like a good example of using the index notation? Like for example, if I take a look at the sort, which does a similar thing, right? It like the sort is very careful to like do things in the form of like like they do this
Paxton,
sort of
yeah.
unwrap notation, unpacking notation. So maybe I have to do it that way.
It's interesting. It's like this dot A dot B. What if you just change like A dot B to A dot C or something? Then what? Is it just an arbitrary label? Or does the A and B actually mean something?
Um, well, I think this is just I think it's actually like a variable name. I think the dot is a little bit misleading.
Okay.
Um, so presumably we could just replace A dot A with A dot C here. And if we try and run the sort, sorry, if we like scroll up to the sort, sort dot bend. I should have run it with the, sorry, let me run it with this C. I don't know why my terminal is glitching out. Run C sort dot bend. Sort dot bend. Yeah, so it gets the same value. So it's really just, I mean, C versus A, it's really just like a variable name. It's sort of like interesting, like trying to namespace it a little bit. So if I go back here, I mean, the sensible thing to do would be to say like, okay, but how exactly does it work here? It's like a parenthesis. I want to do it exactly the same way. So I want to do like A dot 1, A dot 2, A dot 3, A dot 4 equals A. That equals B. A zeros should become A dot I, B dot I. Yeah, I need to command my editor to use like 2 spaces because this is getting annoying.
There's an option
Indent.
detect and okay there.
Okay. And so now let me try and do the same thing over here. This is what I want for A. This is what I want for B. The A0 should come. Okay, well, the should become dot this. The one should become dot two. Two should become dot three.
You just wrote 3.
Yeah, my
Like,
bad. Dot I. And the threes become dot IVs. Yeah, makes it like horribly the like the spacing is now all messed up, but by using Roman numerals, we've avoided the possibility that like numbers aren't allowed in names. Okay, so what happens if I try to run this now? Result equals
3.
3, which is still not the right value. Oh, because I'm
Oh,
doing
yes,
this, right?
return C. Yeah.
Okay, well, what happens? So I can return A, and let me just check that this is the right value. Yeah, so it's this. What happens if I return C? 2,
2.
3, 6,
Yes, that's
11.
correct.
That looks correct.
Okay.
Okay, cool. And then presumably I can change D to be equal to 2, and it'll do like a higher order value, 84 being the top one. So I think like, let me just check that the 84 top level value is right. So I would expect it to be
Okay.
something that goes 0, 1, 2, 3, 4, 5. So I would expect the top row of the matrix to be 0, 1, 4, 5. And then the left column of the matrix, I would expect to be 0, 2, 8, 10. Um, so like 0, 2, 8, 10 against 0, 1, 4, 5. 50 plus 32 is 82 plus 2 is 84. Yeah, so it looks like the top right value is correct. The top left value is correct, sorry. Okay, cool. Seems like we have an implementation of matrix multiplication.
All right. Which one did you run? So you just ran it as is. Okay, let's make a bigger matrix.
Yeah,
5.
let's go crazy. So 5, how big of a matrix
32
would
by
this be? This would be a
32, so like
32 by
900.
32 matrix. Yeah, for sure.
Now we're talking.
Nice.
And I'm just gonna
Um,
assume that's right. It took like point. Okay, and let's just okay. Try run C now. S- See what kind of parallelization we get.
yeah,
We
so
get a
this took,
factor of 10. Not that much time actually. We might want to bump up the size even more.
okay, we might want to, yeah, for sure.
The thing is that
It's
oh, I'm
gonna
just
make
thinking of
like a
something
massive
that
printout.
printing. I think actually printing out the matrix will be more of a bottleneck than computing it.
Right, so maybe we should just not do that. Is it possible to just say like return D here and it'll take here, let me like return
Oh
D
yeah,
equals 10. So this will be like 1024 by 1024 matrices.
let's test this.
Looks like it's taking some time. I mean, it
Let's give
should
it
still
like 30
compute it all,
seconds.
right? Because it's being told to evaluate C here,
Yeah,
so it should. Okay, here,
unless
let me
it's
like step up
overly
one at a
clever.
time. Okay, so 6. Let's see how it takes for 6. It takes 9 seconds. Okay. With 7, it takes
Okay,
1.312. Is this like vaguely consonant? Like, okay, naive matrix multiplication is an n cubed algorithm. So we're going at like every time we double the size, we should be doubling by a factor of about 8. Let's see what happens when we go D up to 8. So like prediction should be that this will take like 12 seconds or so. Yep, took about 10 seconds. Very cool. And if I were to do it with 9, it would probably take around 80 seconds. But rather than doing the one that takes 80 seconds, let's try and do this with run C rather than
yeah,
um, just run.
doesn't seem much
This is
faster
this is
or
taking
at
much
all.
longer than I expected. Yeah, wow.
Uh,
So like 10 seconds versus 8 seconds. I wonder if it has to do with like the bandwidth of like moving the matrices around, right? Because the first thing that we do, right, we have the first thing we do is we generate A, the matrix. And
Yeah,
then the next thing we do is we generate B, the matrix, and then we like have to pass those values into the matrix multiplication. I wonder, like my concern is that perhaps what's going wrong is that it's too much. Like while it is in principle possible to parallelize, like too much of the like work for the parallelization is going into like moving data around, and that's why it's being sort of um, less sped up by parallelization than we expect.
We could inspect the code that it generates. Because I mean,
Let's see,
like
is
from
that
the name, it's
possible?
supposedly generating C code. So let's see. If you just run bend-h in the terminal, it'll give some options probably.
Okay, so we can compile the program and run it with Rust, C, CUDA, compiles the program to HVMC and prints to standout. Okay. Check desugar. Okay. So we could compile the program to
Yes.
standalone C and see what happens. Let's do that. Let's
Okay.
gen C.
Remove the time command.
Oh, yeah, I guess that's sort of pointless. But nevertheless, it is generated.
Static constant book buffer.
I don't know what all of this, like all of these numbers mean.
Tree sum 28, tree sum 26. You
Grading
might want to
sort.
swap
What
more.
is all this like?
Actually, here, just pipe
So
it into less, because otherwise scrolling's gonna be a pain in the ass. You've got 17 more to
okay,
go.
less. Okay, type
Requirements.
def, uint8. Local types, threads per CPU. So it knows my CPU has 10 cores. That's nice. Interaction rule values. Okay, so this seems related to like the interaction calculus, perhaps.
Yeah, I see like erase, annihilate,
Right.
create,
Like what is it? Like
and
are there like supposed to be exactly eight
switch.
like operations or something?
I don't know actually.
I, weren't there like six? I thought like when I was reading about the interaction calculus, I thought there were like he boiled it down to like six different combinators that were supposed to be used.
Global max 16,000 high priority and 16 million low. Interesting. Max of 536 million nodes.
Right. So the whole point is that it compiles the entire thing to a large like system of nodes, which it then reduces.
Missions. Scroll.
So we shouldn't necessarily be like expecting to see like, oh, this is where the matrix is. We should just like see like a very large like all of it seems to me like most of this C code is going to be about like dealing with the nodes and probably the like book buff
Yeah.
stuff at the end was just some like random
Well,
encoding that the
we can skip
okay,
that
let
a
me
bit faster then.
constructors and getters,
I am actually finding
swaps to
reading this helpful
ports.
nonetheless.
Yeah. So like swapping ports. Ports is like the name of the ports is the name of like the end of a wire in the interaction calculus. So every node has like a number of ports that it would go in and out of it.
Wait.
Spin weight using a top operation, atomic operations, global sum function, ports, pairs, rules. Okay, so here we have some stuff related to, okay, bool is node. True if this port has a pointer to a node, sure. True if this port is a variable. Given two tags gets their interaction rule. Okay, so we have this like matrix, this like table of what's supposed to happen for every pair of things, right? We have the annihilation operations here and the commutation operations here. I vaguely want to like scroll back up and look at like what these like 8 things are again. Like
Direct
what's the name of
erase
the paper?
number. Uh, his paper.
The like if, where what was it? There was a paper, it's like all based on the interaction calculus of like his name was like Yves Lafont. Yeah, this guy. Um so
I'll look for
passes
him.
Turing machines. So this is the like PDF I was reading.
Yeah, I haven't seen this one. Printed in belt. Okay.
And we have all these lovely string diagrams. And this everything that I'm reading here, like he explains how you can do like addition here. You can reduce nets, and you have like all these are the interaction rules, and there are these like commutation rules.
These are the ones
And
that get animated in the website.
yeah, for sure. Wonderful animations. Yeah, like the logo, even the logo. I remember like looking like up here,
Yeah,
it's basically
nice.
demonstrating like a like commutation. Very fun. Um, but so presumably the like 8 values here, like 8 different port A, port B, static inline rule, get rule. Given two tags, gets their interaction rule. So we have some interaction rule. And the thing is that like each of the interaction rules has like a particular, some of them are commutation, some of them are annihilation. Like duplication is this is the main one where this one goes through this. I'm not necessarily like seeing like so this is presumably the erasure uh, combinator. The erasure combinator, I think is what it's called.
What's
Okay.
number?
Yeah, possibly. I mean, like there's like wonderful, beautiful description of how you can do like binary addition using these things, but that's of course much worse than
Yeah.
like, you gotta use like your ALU that's built into your computer to do that stuff. You want to be a serious language, so get rule, just port, nums, sim operation selector. So now we're just doing a bunch of bit masking. And here we have some built-in arithmetic operations. Great. Balance checks are back. Probably like reducible expression or reduced expression.
Operatics. Okay, all their stuff about reading, storing. Okay, well, next. I think we can skim this part. Looks like it just does a bunch of atomics, though.
Yeah, practical. Okay, so this is obviously the name of one of the functions that I created.
Radical
So
MF
maybe it's basically
and
describing what's supposed to
M.
go on there.
Let's. You can actually look at how many values before.
Like maybe this is what it was complaining about the size of. Like it's got so much stuff going on because I was passing
I
quadruples
think
to it.
so, because let's see. Because look, after val v9, it goes to v a b c
Right.
e f. That's 10. That's 15. Or it starts with 0, so that's 16 values. I think it actually is then.
Hmm.
And there should be 16 values for n too. No, but there are more.
That would be like I don't know
There are
why
more
that
than.
like 16 would be like an order 2 matrix, but I don't know why that would like show up in the code in particular. What is going on? Oh no. Right, call Jen. Maybe these are like this like match expressions or something. And so here we have Matmo, which is its own really long implementation.
Is that all in one function?
Yeah, it looks like it's a really long function with a bunch of if statements.
Actually, wait, what are these if statements? If something is not none, link, else, make a new port. Okay, if something exists, then do.
Right. Just like make new ports, like make a subprocess to handle like the multiplication of this like submatrix or whatever. I think that that is probably as reasonable an explanation as any. And then we have some more interact calls. There it is, interactions, evaluator. So we
Evaluation.
have something
Geeks of
evaluates
Redux. Oh,
it.
this is stealing everything. This will steal Redux. Um, chill. Normalizing. Oh yeah, this was part of his website's explanation that when no more reductions can be done and you have some graph, converting it to an object, like a number or something.
Yeah,
Like you had mentioned earlier, well, yeah, for it to be a serious language, it'll have to tap into the ALU.
yeah, makes sense.
What is monadic
So we
IO?
have monadic IO. Okay, fun.
Monads are something I learned in Haskell like a bunch and then did nothing with working in other languages and then Lean, which has them
Hmm.
again.
Yeah,
Thankfully with auto lifting.
draw image. I wonder if
Draw
like is
image?
there
What image is being drawn? Image rendering is a work in progress. You must generate a C file with HVM Gen C, manually uncomment the define IO draw image,
okay.
have SDL
Okay.
installed and compile it. Okay, but what could I draw with this? The other
Well,
functions exposed
presumably,
for
okay,
it?
it's like the graphics processing units are supposed to make graphics, right? So presumably, uh,
Hmm.
there's ideas of making the language like do
I
graphics processing.
I have to admit, I genuinely forgot that GPUs are mostly used for that. I'm so been into AI so long that that's good. Load the book. I think we can skip that part.
Okay, so this is we're getting like back
Go
down to where we were with the like book.
stress
So these
test
are
2 to the
demos.
18th times what I think is supposed to be 2 to the 17th. The bitonic sort. They're just built into the source code. Okay.
Yeah, that's a little weird. Like Pythonic sort. Are these like the example values? I don't know why they're appearing in the compilation for my code.
Matmul. I think it is because I remember that exercise he has with 2 to the 18, and that number's familiar.
Oh, okay.
Okay, so the
Well,
code
I
dissolved
I'm
into recursion.
yeah, the code. code looks good. And then we have some like some printing some things at the end.
Yeah, you were
Okay.
saying just before your something.
Yeah, I was gonna say that I'm gonna like probably want to take off in
Okay,
like
yeah.
15 to 20 minutes because my father is visiting me. So I'm gonna like want to go meet him.
Okay.
So maybe this is a good place to like cut off the stream for tonight, or at least for me to cut off the stream from my end. You can obviously keep streaming. Here, do you want to like do you want me to like send you this file that I made in case you want to continue to play around with it?
Yeah, send it to me in a gist. I am also gonna
Yeah, for sure.
take a break and cut the stream. We got a Matmo running correctly,
Ugh,
so
where's the
I'm
button
reasonably
to make a new
satisfied.
just?
I also discovered what's good and not good about this. Good, it does seem to get paralyzation, so I can believe that with more support, it would, well, I'm more inclined to believe it would work. Is it at like the level he's claiming? I don't know. It did get what looks like near peak utilization.
Yeah, like yeah, that's definitely like an important factor for parallel programming, getting like utilization. And I'm not
It,
I never know
indexing in
like
it is
how
very
that's
confusing.
yeah, like it like getting the like functional like list definition to work maybe seems like something that would also be good to do, but and just like for now, I was like with this code, I was just sticking with the way that it seems to consistently be done in the demos. Okay, well, nice to meet you. I'm gonna stop sharing now and take off.
Okay.
Take care.
Yeah. All right, my guys. I'm going to do something else.